Welcome back to the fifth episode of this playlist, and today we are going to discuss the following problem number 1.5, and the problem's title is One Away. So the problem states that there are three types of edits that can be performed on a string, which are insert a character, remove a character, or replace a character. So we would be given two strings and we need to write a function to check if they are one edit or zero edits away. So for the first example, this returns true because yes, they are one edit away because A can be added for the following string, which is PLE, and for the next example, for pails and pale, we again see that this returns true and it is again one edit away because S can be removed to form pale, and for this edit pale and bale, again this returns true because only B needs to be replaced with P or P needs to be replaced with B to form the exact string. And for a string that would have pale and pale both same characters, that would also return true and would result in a zero edits away. So it's a pretty easy question, and let's solve this problem. So I'll name my file as one away, the title of the problem, and I'll comment out just the problem statement that we're going to check that how many edits are to given strings away. So we would probably follow a brute force approach for this example, for this problem, because it does not has a lot to do with any data structure as far as I could think of it. Uh, if else would go well with this sort of problem, and I'll name my function as edits away, and I'll keep the return type as boolean because that is what the question's example states. So I'll name my first string as s1 and the other string as s2, and now inside this what we're going to do is that I'm going to store the lengths of both of the strings at first, and now for the other string I'm going to create another variable called L2 and going to store the length of string s2. So now as we have stored the lengths of both the strings, so we could directly first of all check that if both the strings are same, then we should generally return true because there would be zero edits away. I should also comment it out, zero edits away. And if the length of both the strings have a difference that is greater than 1, so that would obviously indicate more than 1 edits away. So in that case we should return false. So if uh, more than 1 edit away, we would simply return false for that case. And for this we would use the following if logic, that if the absolute value of the length difference between both the strings is greater than 1, we would generally return false in this case. And now moving on, what we now need to do is that we now simply just need to check that if both the strings have a length that is equal or length which is equals a length difference that is equals to 1. We don't need to just check for each character. So for that we could just create our following variables. Integer variables, I could name them as I and initialize them with 0, and another variable j, initialize it with 0, and another variable count which I could again initialize with 0. And now I can use the while loop, that while the uh, variable ith index is less than the length of the first string, and along with that the jth index is less than the length of the second string. So now for this while loop what I need to do is that I could check that if the s1's ith index is equals to s2's ith index, that would mean that both the strings have the same characters at this specific indices. S2 is jth index, by the way. So for this case, what I need to do is that I could simply increment ith and jth pointer, and then for this would be generally for the if case, and now for the else case, if these are not the same, then we would simply increment count to keep a track that it does not exceed 1 in that case. And now inside this else statement, what I could do is that I can check that if my count exceeds 1, then I could simply return false again, as I explained earlier. And then I could again use an if statement that now if L1 is equals to L2, so what I could do is that I could again increment the ith and jth index, and else if I could use that if now my L1 exceeds is greater than L2, now in this case I would simply increment my ith pointer, and for the else case what I could do is that I could simply increment my jth pointer. So I think this should pretty much do the work for this, and at last what we could do is that we could simply return true in this case. Yeah, so this should work. By the way, I think that I should keep all of this inside. Yeah, I should keep it inside the else part. Yeah, like this should work now pretty much. Yeah, so now let us test our following code. And yeah, so what we should now do is that we could simply print out our answers for this function. I named my function as edits away, so I could see out edits away, and I could then uh, pass it the examples quoted in the book, for example pale and ple, and just yeah, so for this case it should return true in this case. So let us see like if our code works for this example. Yes, so it returned 1. That means that our answer was true for this case. And what if I used bool alpha? Yeah, yeah, so now you could see that it returned true. So now what I could do is that I could again test it on other strings as well. So again, for passing arguments to our function, I could now pass two strings that are exactly the same, that are 0 edits away, and you could again see that it should return true in that case also. So if I pass pale and pale again, so it should again return true for this case. And now we could check for a false case again, in which it should be more than 1 edits away. So for example, I choose pale, and for the other string I would choose paying. So this would generally be more than 1 edits away, and it should return false in this case. Yeah, so that would be it for this problem, I think, and see you guys again for the next video, in which I would probably discuss the string compression problem, problem number 1.6. So do like, share and subscribe, guys.